Hello students, this is Indrani ma'am from Rasayan. In this lecture, I am going to explain the order of living group ability of some species. So first we should know what is living group. On approach of nucleophile, the group which escapes from a molecule is called living group. Examples of some living groups are these. Many other living groups are also possible. Some living groups are poor living groups, some living groups are good living group. Now suppose, now see living group is attached with carbon here. G means this is living group. Now we know the base donates lone pair of electrons, as for example ammonia. It is donating its lone pair of electron. So it is base. But here living group is living with this shared pair of electron, or we can say living group is living with the bonded electrons, means it is taking electrons. So remember, the base living groups are those which are least basic. Now see, between OH minus means hydroxide ion and water, which one is good living group? Now see, here donor atom is same, oxygen. Donor atom means the atom which will donate electron density or lone pair of electrons. On OH minus, on oxygen, electron density is more than water. So, if you consider basic strength of these two, since it is having higher electron density, therefore this is more basic than this. And remember, living group ability is inversely proportional to basicity. Since water is less basic, therefore living group ability of water is better than OH minus. Now between OH minus and NH2 minus, which one is better living group? OH minus and NH2 minus both are poor living group. Poor living group. Now between these two, which one is better? How to find out? So first you have to write the structure of conjugate acid of these two. So its conjugate acid means with OH minus add H plus, you will get this. This is conjugate acid of this. And here also add H plus means NH3. This is conjugate acid of this. So you know water is more acidic than ammonia. This is its acid strength. If water is more acidic than ammonia, then what is the basic strength between these two? Its reverse, means this is basic strength. Means this is more basic than this one. If this is less basic, therefore we know living group ability is inversely proportional to basicity. So what is the living group ability between these two? Then OH minus is better living group than NH2 minus. Due to this reason. How to find out the order of living group ability of this species? Now, if you can find out the basicity of this species, then from this relation, we can find out the living group ability order. Now see here, everywhere donor atom is oxygen. Here and here on oxygen, negative charge is there. So obviously here electron density is more than these two. Therefore these two are more basic than this. Now see here, in acetate, in conjugation with this negative charge, C double bond O group is there. Therefore, it is involving in resonance. Therefore, it is more stable. It is more stable means this is less basic than OH minus. So, if you find out what is the basic strength order, since these two are negatively charged, so these two are more basic than these two, and between these two this is more stable, therefore it is less basic than this. Therefore this is most basic, then this one, and here due to plus I effect electron density is more on oxygen than this, therefore next basicity is coming for this one, and this is least basic. We know leaving group ability is inversely proportional to basicity, therefore leaving group ability order is this one. Just reverse this. Now find out the leaving group ability order of halides. These are group 17 elements. Remember, leaving group ability is directly proportional to size. If the atom is larger in size, it can spread out the negative charge. So electron repulsion is less. Once again, if the atom is larger in size, then it can spread out the negative charge. So electron repulsion is less and system is stable. These are group 17 element. So down the group chlorine, chlorine, bromine, iodine is there. So down the group size is increasing, and we have seen since size is increasing, therefore stability is also increasing in this direction. Stability is increasing. Therefore leaving group ability is also increasing from here to here. Or you can say from iodide to fluoride, leaving group ability is decreasing. Therefore, we have seen leaving group ability is proportional to size. Since size is increasing, you can say leaving group ability is increasing. Or you can say leaving group ability is directly proportional to stability. I have explained already. Here another thing also you can say, the more polarizable a group, the more is its leaving group property. Since polarizability is also increasing in this direction, therefore leaving group ability is also increasing. By any way you can give the answer. Now see here, after departure, if leaving group is becoming more stable, then it is very good leaving group. Example of very good leaving groups are tosylate, brosylate and nosylate. Tosylate is OTS, here minus. Brosylate is OBS, here minus. And nosylate is NSO minus. Now, what is the order of leaving group ability of these three groups? We will see this one. Now see here, this group is tosylate group. So after breaking of this bond, means removal of this group, we are getting this tosylate ion. So this part you can write ROTS. Similarly, this part is brosylate group. In short, you can write OBS. After departure, this group is forming brosylate ion. Similarly, this part is nosylate. In short, you can write RONS, nosylate. After removal, it is forming this ionosylate ion. Now, why these three are good leaving group? Because everywhere after removal, whatever species anion they are making, that is stable. In conjugation with this negative charge, S double bond O multiple bonds are there. So these are involving in resonance like this, or you can show in this way also. From both the side, these are involving in resonance. So we have seen this O minus is in resonance with this S double bond O and with this S double bond O also for all the three cases. So these are more stable. Therefore, these are very good leaving group. And nitro is electron withdrawing. It is having minus I effect and minus M effect. Due to these two electron withdrawing effect, electron density will be dragged in this direction, this sulfur is becoming highly electron deficient. Therefore, it is obstructing electron density from this oxygen, and magnitude of negative charge density will be decreased here. Therefore, this system is becoming very stable. But here Br is having minus I effect and plus M effect. But minus I effect is stronger here. Plus M effect is not that much stronger. So due to minus I effect only, it is obstructing electron density from this sulfur in this direction. Therefore, it is becoming electron deficient, but it is becoming less electron deficient than this because it is also having minus M effect. So this sulfur is becoming more electron deficient here than this. Obviously, here negative charge density is decreased in a lesser extent than this. So between these two, which one is becoming more stable? This nocylate. Next is brosylate. But here CH3 is having electron releasing plus I effect and positive hyperconjugative effect. Both is increasing electron density in this direction. Therefore, here negative charge density is less decreased. So, this is becoming less stable than this and this. Therefore, this is best leaving group, then this, then this. Now, can you give the answer of this question? 4 anions are given. The correct order of increasing leaving group capability of above anions. You have to find out this one. Please try to do this. In the next lecture, I will give the answer. If you like, please do like, share. Thank you for watching.